So we've already seen today in our a little bit of maths question for tomorrow that there's an expectation that we can do trigonometry without a calculator, and it is explicitly mentioned on the exam board guidance for this year, so we know it's going to come up. And I'll be honest with you, in years gone by we've crossed our fingers and hoped it hasn't come up, and it did one year and it didn't another year before COVID came along. So we know this year it is going to come up, so we need to be ready for it. The good news is you're not expected to be able to do any sort of trigonometry. You're expected to be able to work out or remember, but I strongly recommend you don't try and remember, the sine, cos and tan of certain angles only. And those angles are this. So I'm going to build through this lesson a little table of values here that we'll fill in. Now the first thing I'll say is 0 and 90 we get from the graphs of trig functions. So I'm not going to specifically refer to 0 and 90 today. I'm going to talk specifically about 30, 45 and 60, because that's probably where it's going to be. However, I will do 0 and 90 as well, if we have time today, and if not, tomorrow. So I'm going to do 45 degrees first. And the good news is you only need to think for this for about two different triangles. So this is a great flashcard thing to remember. So I want you to imagine isosceles right angle triangle where the sides are 1 centimetre long. Okay? So the first thing I'd like you to do for me is tell me what the length of the hypotenuse is, leaving it in surd form. So it's an isosceles right angle triangle, so you're going to use Pythagoras, but I'd like you to leave it in surd form. Okay? And this is what I would do if I opened my exam and there was a question on the non-calculated paper with a 45-degree trig question. I wouldn't remember this. My brain hasn't got the capacity. I'd draw that triangle. Jack, is the tripod interfering with you? Let me. Sorry for those watching the video that we've had a bit of. There we go. Back to normal. Right, Arthur, let's not give a running commentary because other people are distracted from what they're trying to do and we'll just tune into you. Ellie?
Is it meant to be that?
Yeah.
You're not asking.
Yeah, there's audio on it, right? Audio on it, right?
I hope Sean watches it.
So it's going to be going through his head.
You have a haircut.
Well, I saw it now, but then
See?
I saw it on Friday.
Yeah, while you were all getting pissed, I was sat at work because I got called in for a birthday party and I had to take the cake over.
So Harry, what's the length of the hypotenuse as a surd? Square root of 2. Well done. And forgive me, I'm going to just take the units out here. So we've got 1, 1, and the square root of 2. Now, and in case you can't see where I got 2 from, 1 squared is 1, 1 squared is 1, 1 plus 1 is 2, square root of 2 is root 2. Right. Now the good news is this is a right angle triangle, but it's isosceles. So these two angles add up to 90. So that's 45 degrees. So I can also use SOHCAHTOA. If that's the angle we're dealing with, then this is the hypotenuse, this is the opposite, this is the adjacent. So I'm hoping, as a fraction with a surd in it, you can write for me what the sine of 45 is, using the values from that triangle, the cos and the tan of 45. So using these lengths, see, I'd like to tell you what the sine, the cos, and the tan are. And of course, in a question like the one you've got in tomorrow's A Little Bit of Maths, you only need to use one of them. So you haven't got to remember the whole table. Yes, Katrina? Well, the thing is, Katrina, this is a key moment, isn't it? So once you've written down the sine, cos, and tan of 45 degrees, by all means, provided your shirt's tucked in, and you, yeah, absolutely, yeah. So remember, we're using. So if you get a paper 1 trig question with a right angled triangle with 45 degrees in it, punch the air. Because you know that you've only got to remember that triangle with its 1 centimetre sides and everything's there. Hi. Good morning. Good to see you. Hey. Thank you. So, Hannah, the sine of that 45 degree?
1 over root 2.
Fantastic. Opposite over hypotenuse, 1 over root 2. And well done if you got the cos as well, because adjacent and hypotenuse. So, Roman, what's the tan of 45 degrees?
I don't know.
So, tan, remember, is opposite over adjacent?
1 over 1.
1 over 1, yeah, which is actually just 1. Actually just 1. So, in a minute, we're going to have built up this big table, but the great news is you don't need to remember the table. You know, I mean, some people do. Some people do, and if you look on Maths Watch, it gives you this bizarre way of remembering these values using fingers and everything. I'd really strongly recommend you don't, okay? You know, learn a language with that memory capacity. No, just remember that if you've got a question with a 45 degree angle, you've just got to remember that triangle. Now, let's go back to the question we're talking about. 30 degree. Right, okay. So, not useful in this particular question. So let's think about an alternative approach if we want to deal with 30 degrees. And this one we did before. I'd like you to think about an equilateral triangle where the sides are 2 centimetres long. So for 45, all I've got to remember is isosceles, right angle triangle with sides 1 centimetre long. Well done, Katrina. Straight there, straight back in 3 minutes. Now, Ollie, I see no 30 degree angles here, only 60 degree angles. I also see no right angles. So can you remember what we do in this situation?
You split the triangle in half.
Genius. Oh, brilliant. Okay, so what I'm hoping is you can, now I've got a right angle triangle, you can tell me what this length is and this length is, and you can then work out the missing length. That's Pythagoras. Note that the length we're after, the height of that original triangle, isn't the longest side. So you've got to do a bit of Pythagoras in reverse, haven't you? Now ignore me for the moment, I'm just drawing it twice, you'll see why. So no calculators and everything in third form.
Because that's squared. That's squared is 4.
Hang on. What, how long is that? How long is that, Joe? Yeah, well done. Listen to Tommy. Listen to Tommy. So remember, we're not finding the longest side.
No, that doesn't. Maybe that's square. So this would be over.
No,
Because there is a square root that we can make up.
If it's square root
3 squared. 3.
Now, hang on. Tell me what that is.
I'm confused.
Tell me what that is.
That's 2.
So that squared is 4, yeah?
Oh wait, yeah.
And what's that?
That's 1.
So that squared is...
2. 1.
I remember a student saying to me, "Oh, sir, it would be so much easier if 1 squared was 2. So what's that squared?
3.
So okay, so now I know that that's root 3. I'm still not sure where the 30-degree triangle, 30-degree angle is. So help me out, Zach. 30-degree angle. It's at the top. Yeah. Now, got to be careful if it's at the top, haven't we? Because it doesn't change the hypotenuse. That's still the longest side. But it means this is now the adjacent and this is now the opposite. So I'm hoping that now we know those 3 lengths. Oh, goodness me. Thank you, Max. Oh, dear. Do you think... Oh, I've done it again.
So, who was that lady?
She is just a visitor who is visiting us. She's called our school improvement partner, so she's just like someone that comes in. No, it's not an inspection. It's like a sort of it's sort of like having a consultant to help you with particular things. No. She's called a lady. So you go. She's going around just visiting, just get a feel about the school.
Yeah, oh, damn.
I'd love to be part of Offset and just go and judge schools. I think it would be so much fun. I'll go and judge the schools.
So, if you get a trig question on a non-calculus paper with a 30-degree angle, all I've got to remember is this, and cut it in half. Sine is opposite over hypotenuse. I'm grateful to the boys for helping me get that the right way round. And cos is adjacent over hypotenuse, and tan is opposite over adjacent. And you haven't got to remember both of them, because you're only going to get a question with one or the other. Is that you okay? Yeah, sure. Now, why did I draw that diagram twice? Well, of course, I can use the same triangle for 60, can't I? 2 for the price of 1, because that's 60. Lengths are the same. I've got 2, root 3, and 1. It's just this time, and I'll be very careful, hypotenuse, adjacent, opposite. So go on, see if you can do sine, cos, and tan of 60 degrees. Same triangle though. Haven't got to remember 2 different triangles.
Wait, so this is 60 and 30?
Absolutely.
So you can't just double it?
No. 2 for the price of 1.
So you've done it again.
No, I've got it right this time. That's the angle.
Oh, yeah, sorry.
So it's adjacent, opposite, down. But thank you for keeping me on my toes. Yeah, I've given up with my Soto car.
So when you're trying to find
Anything to do with like Sine Cos and Tan, always write that down. Always write that down. So over what are you going to say?
just
So whenever you're given that,
Yeah.
or any triangle,
Oh yeah, so two different dates.
that's involves one of the angles shown on the triangle work out. It's always right.
Oh yeah, that's the then and mine. Yeah. That was my attempt at starting. What I did
Yeah, I can do that.
Jack. Are you speaking for your marks?
Just
Okie dokie, so sine is opposite of hypotenuse,
you cross out the words.
and cos is adjacent over hypotenuse, cos.
The 1 to 10.
And tan is opposite of cos.
Yeah, don't put that
Now, I can understand some people trying to remember this because there are patterns. So, for example, those get reversed there, and you can see a sort of pattern here. But I just think, remember what the triangles are, and then just do it from scratch each time. And that would be my recommendation. Now, good news is we've got time to do 0 and 90. So, I think it's pretty unlikely that you'll get a question that asks you to remember either the sine, cos, or tan of 0 and 90. But if you do, it relates to the graphs, and you are expected to recognise the graphs. So let's talk about the graph of sine x. We have done this before, and I remember a lesson back in Mr. Beasley's room where I got you to work out the sine of lots of different angles, and we found that it followed a pattern. As we increased the angle from 0 up to 360, we got this pattern in the sine of the angle. And, you know, that was just by doing sine of 0, sine of 10, sine of 20, sine of 30, sine of 40. You found that the biggest value you ever got for the sine of an angle was 1. And that's when you got to 90 degrees. It was sine of the angle was 0 when the angle was 0, but also when it was 180 and 360. And the smallest the sine of the angle ever got was -1 at 270 degrees. And you might be saying, well, hang on a minute, how come, you know, trig surely is used in right-angled triangles. I'm not going to have an angle bigger than 90. Well, we use trig in non-right-angled triangles with the sine rule and the cosine rule, but even so, we shouldn't get an angle bigger than 180. But actually, trig can be used in a whole range of applications. So you're expected to remember that rough shape of the graph. And that tells me that the sine of 0 degrees is 0. And the sine of 90 degrees is 1. That's the graph of sine x. We did that some time ago. And really all you're expected to do is to remember the rough shape of that graph. It's not a parabola. It's not a parabola. In fact, it's referred to as a sine curve. And it's the shape of any electromagnetic radiation, and its period, its wavelength is 360 degrees. Okay, so let's talk about y equals cos x. Again, this is just a reminder because we did this previously. We did the same thing. We worked out the cos of lots of different angles. Cos 0, cos 10, cos 20, cos 30, and we found something interesting. You got a very similar pattern to the sine curve. The only difference was that at 0 degrees, the cos of 0 degrees was 1. and you found that you got a very, very similar pattern to the sine curve. It went up as far as 1 and down as far as -1, but it was just shifted backwards 90 degrees. So think about your 360 degrees being broken into quarters. This one goes up to 1 in the first quarter, down to 0 in the second quarter, down to -1 in the third quarter, back to 0 in the fourth quarter. This one starts a quarter later, so it's already at 1. It goes down to 0, down to -1, up to 0, up to +1. Again, you're expected to remember that rough shape of the graph, and it tells me that the cos of 0 degrees is 1, and the cos of 90 degrees is 0. And again, just like 30 and 60, we've got a symmetry with 0 and 90 between sine and cos.
So cool.
What about tan?
I bet tan
Tan
is
is
special.
Special case.
It is, it's always more complicated, tan, unfortunately. We do?
Why is it? Why do they got names?
The ones in 100 degrees.
Well,
And it's sort of
they.
I don't know. It's just weird.
So,
You went all that tan.
I get you.
now the graph of tan x is always a little bit more complicated. The good news is that whereas the graph of sine and cos have a period of 360 degrees, one complete cycle takes 360 degrees. The good news is tan only has a period of 180 degrees. And, Katrina please, the first full copy of that period you get from -90 degrees to +90 degrees. Now you might be saying, what on earth is a negative angle? Well, if I'm turning from here to here, and we call that 90 degrees, I need a different way to describe turning from here to here. So negative angles do give us a good way of describing turning, differentiating between one direction and the other. And the graph of tan goes like this. If you type in on your calculator tan of 90, you get an error because it's one of those graphs that never reaches 90, and ditto for -90.
what does that say?
And so, yeah, what that means is that the tan of 0 is 0, and there is no tan of 90 degrees.
So you couldn't be off.
Again, all you're really expected to remember is the general shape of that graph. The general shape of that graph.
Tan is very special.
Tan is very special. So, looking at that table is a bit daunting. That was Jack, sorry. Looking at that, I'm just talking to those who are watching. Looking at that table is a bit daunting. But the good news is that you're only ever going to need one column from that table. So, you know, it will be a right angle triangle with a 30-degree angle, in which case you just need this column. And to remember that column, you just need to remember that triangle. Or it'll be a right angle triangle with a 45-degree angle in it, in which case you remember that triangle. So there we go. So I encourage you to have a go at the at that one, and maybe on Wednesday, because if I do it in tomorrow's lesson, you won't have a chance to do it. But maybe on Wednesday we'll go through the answer to that one.